Multiplying complex numbers. First couple examples, what we're going to be doing is multiplying by a monomial out in front by a complex number. Then we'll get into a couple examples where we multiply two complex numbers together. All right, so first of all, when we get started on something like this, we're going to find this product. So we have a multiple on the outside of a set of parentheses. I think this should be pretty straightforward, that you're going to distribute that number to whatever's on the inside. So in this case, we think 4 times 2 is going to make 8, plus 4 times 5 is going to make 20 with the I. We have a real part, we have an imaginary part. That's all there is to this problem. Let's try one more here. We have a fraction out in front. So again, you're going to distribute this 1/2 to each term on the inside. Just be careful. Distributive property. So we have 1/2 multiplied by 5. You can visualize that as 5/1. So you multiply numerators, multiply denominators. And then we have 1/2 multiplied by 2/1. With the I comes along. 2 times 1/2, the 2's get to cancel out or create a 1. So we'll make a minus 1I. There's an understood 1 out in front here. So we have a real part, 5/2, and an imaginary part, a -1. All right, next of all, let's talk about multiplying two complex numbers together. So in this case, we have 4 plus 3i multiplied by 2 minus 5i. So two complex numbers. The thing to remember on this is we define the square root of -1 to equal I. So as we get going on this, another thing to remember is if I want to get rid of that square root, I would use a square on both sides. So the square and the square root, inverse operations here, we'd get a -1 on the left-hand side and an I squared on the right-hand side. So whenever we see an I squared, by definition, it's going to equal a -1. So let's take our time and multiply this out. If we ever see an I squared, we're going to replace it with a -1. So jumping over here, distributive property, or first outer, inner, last. We're going to go 4 times 2 makes 8. Outer, we have 4 times -5i, so minus 20i. Inner, we have positive 3i times 2, so plus 6i. And last, we have 3i times -5i makes -15. But then remember, we have an I squared there. So whenever we see that I squared, we're going to have to replace that with a -1. So an intermediate step here, let's go ahead and say I'll bring along the 8. These middle two terms we can combine together. They're like terms. So -20 plus 6 makes -14 i's, minus 15, and then replace that I squared with a -1. Okay, so now we can say this is -15 times -1 makes positive 15. Just trying to take my time, show all my work as we go through this. Everything else came along. So the 8 came along, the -14i came along. This became a plus 15. Now we have two more like terms. We have the 8 plus 15. We can simplify that down to make 23 minus 14i comes along. So our real part's 23, the imaginary part's -14, and that's it. All right, one more example here, very similar. We have two complex numbers being multiplied together. First, outer, inner, last are distributive properties. So 3 times 2 for the first makes 6. Outer, we have 3 times 3i makes 9i. Inner, we have -4i times 2 makes -8i. And then last, we have -4i times positive 3i is going to make -12i squared. But note that I squared, we're going to have to replace that with a -1. So very similar. Bring the 6 along. These are like terms in the middle. 9i's minus 8i's is going to leave us with 1i, where we can just write write I. There's an understood 1 out in front. Minus 12 times, instead of I squared, we can replace that with a -1. So really, this is going to be a plus 12 at the end. I'll go ahead and write it out. This is 6 plus I plus 12. 6 plus 12, those like terms are going to make 18 plus I, bringing the I down. So we have a real part of 18, an imaginary part of a 1 out in front of this I. All right, hope this helps out as you're trying to multiply together complex numbers. Good luck on it.